we have a single neuron. Now let's wire many of them together into a full network. By the end, we'll have rebuilt the exact network that beat the two moons back in lesson 1. Start with our two inputs feeding a single neuron. The trouble is, one neuron can only learn one weighted view of the data, a single straight blend. To capture something richer, we need more of them. So we place 4 neurons side by side. Every one of them reads the same two inputs, but each has its own weights. That gives us 4 different views of the data at once. 4 neurons on the same inputs, that's a layer. Now feed all 4 of those outputs into one final neuron, which combines them into a single answer. And that's a complete network. 2 inputs, 4 hidden neurons, 1 output. This is exactly the network that drew the curve through the moons. Each part has a name. The inputs on the left are the input layer. The final neuron on the right is the output layer. The neurons in the middle are the hidden layer, hidden because we never see their values directly. They just do the work in between. Notice every neuron connects to every neuron in the next layer. We call that fully connected, or dense. Let's count the knobs. 2 inputs to 4 hidden neurons is 8 weights. 4 hidden to 1 output is 4 more. That's 12 weights, plus 1 bias per neuron, 5 biases, 17 numbers in total, and every one is learned from data. There are 2 ways to make a network bigger. Wider means more neurons in a layer. Deeper means more layers stacked in sequence. Both give the network more capacity to fit complicated patterns, but both also add parameters to train, and make it easier to overfit. Bigger is not automatically better. In PyTorch, the whole architecture is a short list called sequential. A linear layer from 2 to 4, then an activation, then a linear layer from 4 to 1. Read it top to bottom, and it's the network we just drew. To recap, a layer is many neurons reading the same inputs. Stack layers and you get input, hidden, and output. Every connection is a learned weight, every neuron a learned bias. Next, the ingredient that makes all this bend, the activation function.